design of this on the left. Now, hello students, welcome to my YouTube channel, VRacademy. We are here to study about digital electronics, and today's topic of discussion is latches and its types with their operations. So first of all, we'll try to define latch, and then I will tell you about the types of latch, how it is operating, and then we will be going for understanding the operation of latch in detail. Okay, so first of all, we'll go for the definition. Now, basically, latch is nothing but a smallest memory element. Okay, latch is a smallest memory element, and it has the capability to store 1 bit of data. So there are 2-3 points you need to keep in your mind while defining the latches. The first point that you should be keeping in mind, that it is a level trigger device. I mean, it works along with the levels, and it is having it is that type of memory element which has the capability to store only 1 bit of data. So if you will keep these 2 points in your mind, you will be able to define it perfectly, that it is a level triggered device, or you can say level triggered smallest memory element that can store 1 bit of binary data. And it can be, I mean, it can store either 0 or 1 in its memory. Okay, now latches, basically when we are going for a latch, we have to study the first latch, that is your SR latch. Okay, SR latch. SR latch. Now what is this SR latch? It is also known as set reset latch. Set reset latch. Okay, set reset latch. Now this set reset latch, SR latch, is designed with the help of 2 gates. I mean, either we can design it with the help of NOR gate, or we can design it with the help of NAND gate. Okay, so we'll try to understand the operation of SR latch individually when we are designing it with the help of NOR gate, when it is being designed with the help of NAND gate. Okay, and after understanding the operation, we'll try to write or go in detail how the operation is occurring and how we are getting the output. So basically, when we are looking about the latch, or when we are thinking about the latch, we need to understand that it is having 2 inputs, that is S and R, and it is having 2 outputs. So whenever we are thinking of a SR latch, you just think it like this. This is a block diagram of a SR latch where we are having 2 inputs, that is S and R, okay, and 2 outputs, that is Q and Q bar. Okay, this is your SR latch in a block diagram format. Okay, now I have already said you that SR latch are being designed with the help of NOR gate, or we can design it with the help of NAND gate. So first of all, we'll try to study SR latch with the help of NOR gate. So SR latch by using NOR gate. Okay, SR latch by using NOR gate. Okay, now, okay, the first thing is its design. So for designing a NOR gate, what you need to do, you need to take 2 NOR gates. Okay, so I'm taking 2 NOR gates. This is my first NOR gate. Okay, this is my first NOR gate, and this one is my second NOR gate. Okay, this is my second NOR gate. Now, after having 2 NOR gates, you need to see how the connections are being made. So what you need to do, you need to extend the top terminal, or you can say the upper terminal of the first gate. I'm just telling this one as G1, this one as G2. So the upper terminal of G1 is extended and lower terminal of G2 is extended. After that, what you should be doing, you will be just having a perpendicular lines over the input, second input of G1 and second input of G2, which has not been extended. Similarly, you will have the perpendicular at the outputs of both the NOR gates, and just put a crisscross. I mean, just have the connection of this output with this input and this input with that output. Just put a crisscross, or you can say just put a X. After putting up that one, you will get the design of a latch. This is the you can say the design of a SR latch. Once again, I'm telling you so that you can understand the design. First of all, you will draw 2 NOR gates. After drawing 2 NOR gates, the upper line of G1 is extended, the lower line of G2 is extended, and you will draw the perpendicular over the other terminal of G1 and G2, and the output of G1 and G2. After having that, just write X, you will be able to get the design. Now, this is your S, this one is your R, this is the output, that is Q, and this is the output, that is your Q bar. Okay, so this is how the representation occurs in case of SR latch. It is matching up with the block diagram that we have drawn. Now once it is done, this is about the design part, or you can say the construction part. The next one is its operation. We'll try to understand its operation. Now in many books or in many of the channels, you will be finding out it has been explained by different kinds of third, but I take the help of normal Boolean expression in order to explain the operation of this SR latch, normal Boolean algebra, in order to understand the operation of SR latch. Now how it will be done? We need not have to think anything about how this value is 0 or 1 and how that crisscross occurs. All these things are just not needed right now. We'll just go for normal Boolean algebra method and we will be able to understand its operation. So first of all, you tell me what is the value of Q. To understand the operation of this SR latch by using NOR gate, tell me what is the value of Q. You can write that in the comment box. Okay. So Q, what is the value of Q? You just see it. The first terminal is having the value R and Q bar is coming from this side. So I can write that Q is nothing but R plus Q bar whole bar. Can I write down the Boolean expression like that? A simple Boolean expression for this one. This one is R, this one is Q bar, and because we are using a NOR gate, so the value of Q remains as R plus Q bar whole bar. Similarly, we can go for Q bar. You can go for Q bar. What is the value? This is S, and from this side it is Q. So it is S plus Q, S plus Q whole bar. So this is the value of Q bar. Now we know that both will have the dependencies, but these are the expression which we have obtained from the general analyzation of these two NOR gates. Now once we are done with that, we'll go for its operation. We'll try to understand its operation. And how you will understand this operation? Now since it is having two inputs, S and R, there are four combinations that are possible. S equals to 0, R equals to 0. S equals to 0, R equals to 1. S equals to 1, R equals to 0, and S equals to 1, R equals to 1. So we'll go one by one. Okay. So the case 1 I am taking, the first case is, case 1 is S equals to 0 and R equals to 0. Okay. Now put the value of S, I am just numbering it. This is my equation number 1 and this is my equation number 2. Just put the value of S is equals to 0 in equation number 2, or R equals to 0 in equation number 1 first. So if I am putting R equals to 0 in equation number 1, so 0 plus Q bar. Now putting these values, I am just writing it, putting the value of S and R in equation 1 and 2 respectively. What you will get? If I am putting R equals to 0 in equation 1, I'll get Q equals to R. What is that? R is 0 plus Q bar. So 0 plus anything is equal to anything. So we'll have Q bar. Once again we'll put up a bar. So that is nothing but Q. So it means we'll be obtaining the same value. I mean, whatever value that is being present previously, the same value remains in the next one. Similarly, if I'll put S equals to 0 in this one. So 0 plus Q is nothing but Q. So Q bar will once again come as Q bar if I am putting S equals to 0 in this expression. So we are getting the same value of Q and Q bar. So we can say that we will be getting Q equals to Q and Q bar equals to Q bar. If I am putting S equals to 0 and R equals to, I am not writing it over here so that it will not be confusing. I am writing it here. If S equals to R equals to 0, then Q equals to Q and Q bar equals to Q bar. We are obtaining the same thing if we are going for case 1. Now, since S equals to R equals to 0 gives us q equals to q and q bar equals to q bar. Hence we can say that this state is no change state. This state is no change state, isn't it? Any one of you can say that. We are not making any change anywhere. So therefore, it is called as no change. Understood? I think it is quite gettable. If we are putting up these equations over here, we'll be getting the same expression. Now, coming to case 2. Case 2. What is case 2? Case 2 is s equals to 0, r equals to 1. And at that time, we'll try to see what happens to the expression 1 and 2. So we'll write once again, putting s equals to 0, r equals to 1 in equation 1 and 2. Just put up these values. So if I am putting s equals to 0, so if I am putting s equals to 0, first of all, in equation number 1, we'll put r equals to 1. So 1 plus anything is equal to 1 plus anything is equal to 1, and bar of that one will be equal to how much? 0, isn't it? Just put up the values and get that thing done. This is q equals to r plus q bar whole bar. So if I am putting r equals to 1, so that means q will be 1 plus q bar whole bar. 1 plus anything is going to give you same 1. So q will be 1 bar. 1 bar is nothing but 0. So that means you are getting the value of q equals to 0. Q equals to 0. Now go for the next part, that if I am putting s equals to 0 in equation number 2, so s is q bar will be equal to 0 plus q. So 0 plus q whole bar. That is nothing but q bar. We have already got the value of q equals to 0. So q bar will be equal to 1. So therefore, we are getting q bar equals to 1. So in this case, we are getting s equals to 0, r equals to 1 gives us q equals to 0 and q bar equals to 1. Now if this is the case, now you look at the output. The output value is coming out to be 0. So if output is 0, we are telling that condition as reset. So this is your case 2. Now we will move on to the other states, that is case 3 and case 4. So we'll go for case 3. What is case 3? Case 3 is s equals to 1, r equals to 0. Now substituting these values in equation 1 and 2. If I will be substituting s equals to 1 and r equals to 0. So if I am putting s equals to 1, in you can go for any of these. If I am putting up, let's suppose r equals to 0. So r equals to 0 is q equals to 0 plus q bar. 0 plus q bar is what? Q bar, and 0 plus q bar whole bar, that is nothing but q. So we are getting q equals to q, that is the same thing which we are obtaining. Next is we have to go for q bar. Q bar equals to s plus q. So s is 1 plus q. 1 plus q whole bar. So 1 plus anything is giving you same 1. So it is 1 bar. 1 bar equals to 0. So that means q bar you are obtaining as 0. Definitely if you are getting q bar equals to 0, q will comes out to be 1. Q will comes out to be 1, isn't it? So therefore we can say that. Now look at the output here. Look at the output. Q is coming out to be 1. Q is coming out to be 1. And q equals to 1 is called as set condition. This is called as set condition. This condition is called as set condition. The last one is case 4. So we'll learn about case 4. This is case 4. Case 4. The case 4 is s equals to 1, r equals to 1. Now substituting these values in equation 1 and 2. So if I am substituting s equals to 1 and r equals to 1 in that expression, you will get Q equals to 1 plus anything is same 1 plus Q bar whole bar is equals to 1 bar, that is nothing but 0. Similarly, about Q bar, you will be getting 1 plus Q whole bar equals to 1 bar equals to 0. So you can clearly see that Q is also coming out to be 0. This is the value of Q, and Q bar is also coming out as 0, isn't it? Both Q and Q bar is coming as the we are getting the value of Q and Q bar equals to 0. Now this is not possible at all. I mean, getting the same value for the complemented state and uncomplemented state is a false thing. So therefore, this condition is described as, this condition is called indeterminate state. Why it is called as indeterminate? Because Q equals to 0 and Q bar equals to 0 is not possible. So this makes us understand all the 4 operations that we have done in case of SR flip-flop. The first condition was S equals to 0, R equals to 0. In that case, we have got Q equals to same value, that is Q bar equals to same value, that is Q bar, which is nothing but this state, which that state is defined as no change state or last state or memory state, whatever you say. The next is case 2, that is S equals to 0 and R equals to 1. Substituting that one have given us Q value equals to 0 and Q bar value equals to 1. That condition is called as reset. Why? Because the Q value is obtained as 0. Similarly, for case 3, we are getting Q equals to 1. That condition is called as set condition. And finally, for case 4, we are getting the value of Q and Q bar both equals to 0, which is not possible, and hence that case is called as indeterminate state. Now, depending on that one, I mean, depending on whatever operation we have studied, we can design the truth table of SR latch. We can design the truth table of SR latch. The truth table of SR latch will look like, now we can have the truth table as S, R, these are the 2 inputs, 2 outputs. What are those 2 outputs? That is Q and Q bar. And simultaneously, we have a comment box. We'll have the comment box where we'll be telling about what exactly is happening while it's operation. So if there are 2 inputs, 4 combinations are possible: 0011, 0101, and then we'll go for its output. We have just got the output. So when S equals to 0, R equals to 0, we are getting Q bar, and we are telling that as no change state, no change. Okay. Then for 0, 1, we are getting Q value equals to 0, Q bar value equals to 1, which is called as reset condition. For 1, 0, you can observe there we are getting 1, 0. That condition is called set condition. And for last one, that is 1, 1, we are getting 0, 0. Or you can say 0, 0 is not possible. Therefore, we are telling we don't know about that, and that condition is called as indeterminate state or invalid state. Whatever you can say, both are correct. Invalid state. So this is the explanation of SR latch using NOR gate. SR gate using NOR gate. Thank you for joining. We'll be discussing about SR latch using NAND gate in the next video. Okay. Thank you for joining.